Hi students, in this video we are going to discuss quadratic probing. In previous video we discussed linear probing technique. Probing means searching. So the disadvantage of linear probing is primary clustering. The disadvantage of linear probing is primary clustering. So if you have not seen my linear probing video, you please watch that video. Then please watch this quadratic probing. Then it is easy to understand. So how to resolve collisions by using quadratic probing. So you know already. So collision means two or more keys are mapping to the same bucket or same mapping address. Then it is called as a collision. To overcome that we are using this. Okay, so whenever collision occurs, then how can we resolve and what is the hash function we will use? Generally, the hash function used, as you know, h of key equal to key modulus hash table size, right? So h of key equal to key modulus hash table size, where key is the element to insert. Now, if collision occurs, so in quadratic probing, what is the hash function we will use? So capital H of key equal to small h of key plus, it has a quadratic probing. That's why I square modulus hash table size, where I equal to 1, 2, 3, 4 and so on. This is the hash function used in quadratic probing. This is the hash function used in quadratic probing. Okay, so now let us start with an example. For example, I want to insert elements like 34, 21, 17, 18, 14. For example, I want to insert these elements into the hash table with hash table size is 10. With the hash table size is 10. Then how can we insert? By using quadratic probing. Whenever collisions occurs, what shall we do? So consider the hash table as usual of size 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. As the index is starting from 0, last bucket number is 9. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so now, so this is the hash function we will use. Okay, so now how to insert? So use the hash function. First element is 34, h of 34. How can we insert? 34 modulus 10, which is equal to 4. So 34 is inserted in fourth bucket. 34 is inserted in fourth bucket. 21. 21 is inserted in first bucket. See, h of 21 equal to 21 modulus 10 equal to 1. So 21 is inserted. Now instead of 17, take another one which we will get collision. 44. So h of 44 equal to 44 modulus 10, 4. What happened here? Here collision occurred. If collision occurred, what shall we do? H of 44 we will write. H of 44 is equal to, I equal to 1. Here I value. Small h of key means small h of this 44. Already we have calculated 4 plus 1 square modulus 10. That means 4 plus 1 modulus 10. That means 5 modulus 10. Remainder. If you divide 5 by 10, then the remainder is 5. Okay. So now 44 is inserted in fifth bucket. Okay. So now, for example, instead of 18, for understanding purpose, I am telling. So consider 54 for example. Now what shall we do? H of 54 equal to, again 54 modulus 10, which is equal to 4. Then again collision occurred. Why? Because fourth bucket is already full. Okay. So now capital H of 54 equal to, small h of 54 is 4. I equal to 1. 4 plus 1 square modulus 10. Already here we solved, which is equal to 5. Again collision occurred. Now what shall we do? I equal to 2. Then small h of key plus 4 square modulus 10, which is equal to 4 plus 4 modulus 10, which is equal to 8. So 54 is inserted in 8th bucket. Next 14. Next element is 14. So now h of 14 equal to 14 modulus 10 equal to 4. 14 modulus 10 which is equal to 4. Again collision occurred for this 14 also. Then what shall we do? H of 14 equal to H of 14 equal to, so 4 plus I equal to 1. 1 square modulus 10, which is equal to 5. Collision already. So then I equal to 2. 4 plus 2 square modulus 10, which is equal to 8. 8th bucket already it consisting of some element. Then what shall we do? I equal to 3. I equal to 3. 4 plus 3 square modulus 10, which is equal to 4 plus 9 modulus 10. 9 plus 4, 13. 13 modulus 10, which is equal to 3. So then in third bucket that element is inserted. So in third bucket. This 14 is inserted. Now what is the next element after 14? 11. Now how can we insert 11? See, h of 11 equal to 11 modulus 10, which is equal to 1. So collision occurred. Then what shall we do? Capital H of 11 equal to, small h of 11 is 1 plus I equal to 1. 1 plus 1 modulus 10 equal to 2 modulus 10 equal to 2. So 11 is inserted in second bucket. Okay, like that the elements are inserted into the hash table. So like this the elements are inserted in the hash table in quadratic probing. Let us take another example. Example 2. So insert or construct the hash table by using quadratic probing. For example, the elements are like this: 11, 21, 31, 41, 51, 61. Suppose these are the elements with the hash table size 10. Apply quadratic probing. Apply quadratic probing. So now, how can we do this one? So consider hash table size 10. So hash table size is 10. So hash table size 10 we will consider 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so now Now consider the element 11. H of 11 equal to 11 modulus 10, which is equal to 1. So 11 is inserted in the first cell or first bucket. Now H of 21 equal to 21 modulus 10. What happens here? So equal to 1. So what is the mapping address we will get? Equal to 1. So again you got 1 only. So collision occurred. Then what shall we do? So I equal to 1 we will put. H of 21 equal to normal hash function. Small h of 21 if you apply 1. 1 plus 1 square modulus 10. Which is 1 plus 1, 2. 2 modulus 10 which is equal to 2. So 21 is inserted here. Next, h of 31. Then 31 modulus 10 equal to 1. Collision occurred. Why? Because already first bucket consisting of 11. So for I equal to 1. H of 31 equal to 1 plus 1 square modulus 10 which is equal to 3 modulus 10. It is 3. So element is inserted in third bucket 31. Next, small h of 41 equal to, oh sorry, here what happened, 1, here it is 2 only na. So 2 modulus 10 equal to 2. Again collision occurred. Second bucket already full. So put I equal to 2. So h of 31 equal to 1 plus 2 square modulus 10 which is equal to 5 modulus 10 which is equal to 5. So 31 is inserted in fifth bucket. So this is first insertion, second element, this is third element, now fourth one. H of 41 equal to, again 41 modulus 10, 1 collision occurred, I equal to 1, capital H of 31 equal, not 31, capital H of 41 equal to 1 plus 1 square modulus 10 which is equal to 2, collision occurred. Then what shall we do now? I equal to 2 we will consider, 1 plus 4 modulus 10 which is equal to 5. So fifth bucket is also full. Again collision occurred. Now I equal to 3. 1 plus 3 square modulus 10 equal to 1 plus 9 modulus 10 equal to 0. So 41 is inserted in 0th bucket. Now next one is 41 completed. Now 51. Now 51. H of 51 equal to, H of 51. See, the same process will be repeated now. Why? Because same type of element. So first it will check first bucket, that already completed, 1, and then next 2. 2 after next one is 5. 5 after next one is 0. Already no need to verify here. I am telling you a short method here. So without solving, again I equal to 1, I equal to 2, I equal to 3. So directly you can go for I equal to 4. Why? Because 1, 2, 5, 0. 1, 2, 5, 0. So all these positions are full collisions. So then that's why put here I equal to 4. Then capital H of 51 equal to 1 plus 4 square modulus 10. 17 modulus 10 which is equal to 7. So 51 is inserted in 7th bucket. Now see the next one, H of 61. Then for this also the positions here are first 1, it is full. Okay, next here it is 2 full, 5 full, 0 full, 7 full. So I equal to 1, 2, 3, So this is normal hash function I equal to 1, 2, 3, 4 completed. So what shall we do now? We will check with I equal to 5. So h of 61 equal to 1 plus 5 square modulus 10. So 1 plus 25 modulus 10. So 6, 26 modulus 10, it is a 6. So 61 is inserted here. Like that, in the quadratic probing, the elements are inserted like this if collision occurs. Now see here, this is another example. This is quadratic probing and this is second example. So now what is the disadvantage of this quadratic probing? The disadvantage of quadratic probing is secondary clustering. The disadvantage of quadratic probing is secondary clustering. What is this secondary clustering? So secondary clustering, primary clustering means sequentially in a cluster. That means these are the cells in the bucket. These are the cells in the bucket, for example. So by linear probing, so you will get one cluster here. So this is one cluster, for example. This is another cluster, for example. So sequentially it has to check for an empty cell. From here to here, from here to here. After this again it will go to 0th cell, like that. Linearly it will check. So that's why this is linear probing, and the problem here it is primary clustering. Okay, so now in this quadratic probing, so it won't verify the successively. Why? Because it is not like I equal to 1, 2, 3, 4. What is the technique here? 1, 4, 9, 16, 25. Like that, h of key plus 1, similarly h of key plus 4, h of key plus 9, h of key plus 16, h of key plus 25. Like that it will check. Not in the linear fashion. That's why here it is called as secondary clustering. So hope you understand, students. So this is another collision resolution technique in open addressing. So that is quadratic probing. So hope you understand. So if you have any doubts, so please send me a message in the comment box. So if you like the video, please share with your friends and subscribe the channel. Thank you, students. Have a great day. Bye.